So these are the important topic. In this we are going to see LiAlH4, that is lithium aluminum hydride, and SPH, that is sodium borohydride, that is NaBH4. Their reduction properties we are going to see in this video. In this you will get some confusion. What if there is a deuterium here in LiD4 it is there, or D plus D2O is there, then what you should do. So this is the video on this. So here first thing we have taken a organic compound, and here I have used LiAlD4 H plus H2. So what is the important thing is, this LiLH4 or SPH, that is NaBH4, they are the source of hydride. They are acting as a reducing agent over here. So what they are going to release is, they are going to reduce hydride ion, that is H minus. So as here deuterium is present, what is going to release? D minus. So let's polarize this bond. See, if you go by the way of mechanism, it's going to be quite complicated, and this is the easiest method, and even you can understand how will it is going to attack that site. So here D minus is attack positive side, so here O minus, and D is attacked over here. Now we are going to do hydrolysis. In hydrolysis I have used H plus H2O, means what is going to release? H plus. So right here H plus is going to attack this O minus side. So what is the final product is? This is going to be the final product. So that's it. So it can save your 4 marks. Now here you can see we have a ketone group, and we have LiLH4 and D plus D2O we have using. Now what's going to happen? H minus, which is going to be which is formed because of this LiLH4, is going to attack. The first thing you should do is you have to write what they give. LiLH4 give H minus, D plus D2 is going to give D plus, and here and over here you polarize this bond. So here you are getting O minus, and here you are getting a positive charge. So H minus will attack here, D plus is going to attack O minus. So it's very simple. Now what you will get is O D. Here CH3. Here you are going to get a hydrogen, and here as it is. Okay. Now in this case we have two one we have aldehyde group and a ketone group. Now here I have used D plus D2O. Nothing is going to happen. You are going to take 2 moles of this. So it's very simple now. This is O D you are going to it. Here you are going to it H, and here same way OD, and here H. So it's very simple. Now another thing is, when you have this kind of complicated thing, there are 2 sides to attack. So what is going to happen in this case? You have a lithium aluminum hydride over here, you have a double bond, and you have a aldehyde group too. Now what is important is, if you have seen this, just a minute, in this chart I have located that LiLH4 is going to be a stronger reducing agent than SPH. So LiLH4 is going to reduce all this thing to this thing, but SPH is going to reduce imine to this and aldehydes and ketone. All other groups are not going to get is going to reduce only ketones, aldehydes, imine group, which imine group is quite unknown to all of us. This is imine group, is going to convert into our CH2NH2. And remember, that's very important, alkyne, alkene and benzene are not going to get reduced by the presence of LiLH4 and SPH, as it is a very weak reducing agent. So let's move here. What I have told is, so it's not going to get reduced because it's alkene, so no problem. Even it's LH or SPH, they are not going to disturb this alkene group. So for both of these the product is going to be same, which is CH2 double bond CH, CH2OH. Now how do we do this? It's same as how we have done this. Okay, now here you have the same thing. Once again the same thing I am going to repeat. This is not going to get reduced and the answer is going to be like this. So it's very simple. You have saved once again your 4 marks. Congratulations. Now this is a quite interesting thing. Now this is a quite confusing part. What if we have a cinnamise system? Then what is cinnamise system? It's we have a phenyl ring, and over there we have a conjugation in carbon-carbon and some other group. So in the cinnamise system, simply we are going, I have a trick. If there is LiAlH4 is going to react with the cinnamise system, simply their double bond reduction is also going to be a major product. Means in the product we are going to reduce the double bond as well as the carbonyl group, and if SBS is present, it's weak, so it will not reduce double bond, only carbonyl group is going to get reduced. Now I have this question. So what I have told, same the question I have written over here. Here we have cinnamise system. If we are using LH, the product is going to be this one. For the first time you may feel it's confused, so you remember this thing once again. So we are going to get this as the product. You know, this is a single bond over here, not a double bond. Sorry for this mistake. And over here we have SBH group. So simply it's going to be like this. What I told is SPH is weak. That's why. Now this is a very important exception over here. You can get a direct question, nothing to do in this. What is going to happen is this double bond is going to get into CH2OH, like CH2 and OH, and this is also going to reduce only in this case because we have used SBH and ETOH, which is a strong base. And it helps it to act as a catalyst over here, and only in this process only we are first time ever we are getting this double bond is also getting reduced. So this is an important example. And thus thank you for watching this video.